Alright, so let's get into running our Python code. So we're taking all our images that we took that night and we're running our HSV mask over it. And we're going to turn those into these black and white images that you see here. So we've demonstrated this before, and I'm cycling right now through each of my angle measurements. I'm just going to give you one side that we're looking at the moment. And you can see that white line is just a laser line. It's been dilated a little bit it's probably not needed, but anyway, so right now we're just cycling through each image, and you can see in the lower left hand side what angle number we're looking at. So if you remember from before, each image is titled with its angle, and then we run the HSV mask, and later on this code is going to go through the geometry, the triangulation geometry, and we're going to locate our object. Alright, so here I'm going to demonstrate some of the MATLAB processing of my data. So first I imported all my data into these files, so front, left, right, and back. And then I kind of set a target distance, how far away I was from the target. There's some geometry to be done each and every time I put my data in. Everything was in its own frame of reference, obviously. It's all being in the frame of reference of the camera. So when I'm on the left side, in the front side, the right side, whatever, I need to pick one frame of reference, either front, left, back, right, to where all my data is going to be looking at, and is going to be looking from, in order to make a 3D plot. So in order to do this, I decided that I want everything to be in the front frame of reference. So front data, I don't have to do any geometry or manipulation. I can just load that stuff right in. X, Y, and Z coordinates. Next, I'm going to be putting the left side into the front frame of reference. So I had to do some simple geometry, which I'll show, in order just to figure out how my X and Y points are going to fit into that frame of reference. And as you can see, I've ended up pulling in the D, the distance away from the target. Then I had to do some adjustments to my Z values, so the ground was a little bit lower on that side, so I had to pull it up a little bit. Now I needed to put the right into the front frame of reference. This was the hardest part because the right side, my measurements, I couldn't get in a good location, so I had to take it at a 40-degree angle. It's really easy when everything is just taken at 90-degree angles from each other. The geometry becomes really easy to deal with. But when you're at a funny angle like this, then you have to take into account a lot more trig. So that's all done here through some vector algebra. This would be if you were to just keep it at a 90-degree angle, which is incorrect. It doesn't work. So you have to do this stuff here. And those calculations were not too bad. It was a little bit higher, so I had to take it down 10 inches in order to make it fit. The next is putting the back end into the front frame of reference, and this was taken at a complete 180-degree angle from the front, obviously, so the algebra was pretty easy to figure out how to place that data in there. And lastly, I'm going to clean up the data. So when I'm saying clean it up, I'm just filtering out some data that I don't want. So for instance, anything that was beyond a certain value, it's too far away from the object, I just want to eliminate that. So this was done here. Basically, it's going to read each and every array of data for the Y measurements, and if it is beyond a certain measurement, then it's going to write all those rows to 0. And the same was done for Z. Z in this case was me just kind of eliminating all the data that was taken off the ground. I left some of it there, but I I took a lot of it out because it just created a lot of noise. It's kind of hard to see the 3D plot well with. And lastly, I'm just plotting all my frames of reference in here. So let's go ahead and take a look at the actual data. So it looks like a big mess initially, but you can see a couple of good landmarks. First, let's start. Here is that base, a little base underneath of the statue. And then you can see the ground level here. That's the ground data that I kind of left. And there is sort of these flowery pieces here that you can see, and that's from like the sort of gun shell design at the top of the statue. And let's take a look from above. Alright, so here you can clearly see the outer hoop. The outer hoop would extend, you know, all the way around, but I wasn't able to take enough data while I was out in the field the other night. You can also see this is from the front end. If I'm looking at the front from the front side, the outer hoop kind of extends out like this, and then there's some more complicated geometry in here which is sort of hard to handle, but you can just see where they both kind of split off there. Now if we look at the back end, again, this is where the back end of the hoop comes off, and there's this big bucket kind of object that comes up here. It's another curved surface. So all these curved surfaces came up fairly well. Last thing I want to look at is the side wall here. It's a flat surface, and it has like this little piece that juts out here, and that came out well. And then there's another bucket end up on this side that's rounded, which came out fairly decent. Overall, I would say there needs to be a lot more data taken of this object. My object is fairly large, as you can see, ranging from like -40 up to 50 inches, so 90 inches tall by roughly 60 to the farthest point out here would be around 80. So, you know, 140 inches wide. It's got a lot of geometry to deal with, and 4 scans would work on, you know, a smaller object, but in my case it looks like I'm only getting probably 20 inches worth on each scan, with like a pass of 20 inches. So in order to get all of this, I would imagine getting this full ring would be 1, 2, 3, 4, 5, 6, maybe 6 scans on that side, maybe 4 in here, you know, another probably 6 to complete up this backside, and that might be good. So I got a lot more data to take. Because of the issues I had the previous night, I wasn't able to take as much data as I wanted, since my equipment fell over and broke. But this is a decent start for now. So not a complete win, but we do see our object in there, and if you think hard and use your imagination. So more data will be taken.